Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily lead code problem, and the problem's name is relative sort array. So you will be given two arrays, array 1 and array 2, and elements of the second array will be distinct, and all the elements of the second array will also be present in the first array. Okay, so you have to sort the elements of the first array such that the relative ordering of the items in the first array is same as that of uh, array 2. Okay, and each elements that do not appear in the second array, first array elements which are not present in the second array elements should be placed at the end of the first array in ascending order. Okay, so for, for example, if the array given to you is like this, A, B, C, D, and then H and I. Okay, and this is the array 1, let's say, and this is the array 2 that is given to you, and it is A, C, D, B, and yeah, that's it. It is still here only. Okay, so you have to first of all arrange all the elements that are present in both of the arrays in same relative order as per the relative order of array 2. So after arranging this section will become in array 1 A, C, B, D, and then B. Okay, and these two are the elements which are not present in the second array but present in the first array. So this should be they should be in ascending order. Okay, so let's say instead of HI it would have been I and H. So you would have written it into ascending order in which H will come first and then I. Okay, so this is what you have to achieve, the relative sorting of array 1 with respect to array 2, and the remaining elements should be sorted in ascending order. Okay, ABCD can be taken as 1 2 3. Okay, I have just taken lowercase English letters here instead of digits or numbers, you can say. So this is the whole logic what you have to do, and before thinking of an approach, let's have a quick look at the constraints. So the length of the both of the arrays will be of order 1000, and each element will be of order 1000 in both of the arrays, and all the elements of second array will be distinct. Okay, and each element of the second array will be present in the first array. So these are the constraints. So let's think of an approach. The very first approach that is coming to my mind is, for these elements which are present in both of the arrays, you can have a frequency map. Okay, there might be a scenario like this: A is repeated twice. Okay, so you should be doing something like this. Okay, so that's why we need a frequency map where the key will be the number and the value will be its frequency. Okay, so then you will visit the second array once you have populated the frequency map with the help of the first array. Okay, and entries will be like A is appearing twice, B is appearing once, C is appearing once, D is appearing once, then H is appearing once, I is appearing once. Okay, so this will be the frequency map for the first array, considering this duplicate A also. And a thing that is here to be noted is, instead of doing the sorting thing at the later part of the implementation, what we will be doing is, we will be using, let's say if we are implementing it in Java, then you can have such equivalent data structure in your choice of language of your choice. So we will be using a tree map. Okay, what this tree map does is, all the keys are kept in the sorted order. Okay, and by default this order is ascending order. Okay, so because of use of tree map, all the keys will be kept in sorting order. And then what we will be doing is, we will be visiting the second array character by character, and we will be seeing, okay, we have visited A, what was the frequency of A in the first array? Okay, A was appearing twice. So what we will be doing is, we will be adding two entries for A, then we will mark the entries of A as 0 in the frequency map. Okay, then we will come to C, and we will see what is the frequency of C. So it was 1 only, so we add just one value, and then mark the frequency of C as 0. Then similarly we will keep doing it. For D we will mark it 0 and add the entry. Okay, then for B we will add the entry for the frequency number of times, which is nothing but 1, and mark its frequency in frequency map as 0. Okay, so now once we are done with traversing the second array and forming partially forming our the sorted relative sorted array, okay, the first array, then, and you might ask that how we will be adding the characters in their place. For that we will be using a index variable. It will be initially set to 0. So you will be starting from the 0th index, and then you will keep upon adding the numbers in the respective indices. Okay, once you have added a number at an index, you will increment the index at which next insertion is to be done. Okay, so then you will again go to your frequency map after you have done your work till here. Then you will check, are there any you know characters which have left frequency, unused frequency, or you can say frequency whose frequency are not 0. So you will find those characters, and they will be appearing in sorted order when you will be traversing this tree map. So then you will be adding H once and marking its frequency 0. I mean, it is not necessary here, as we are already on the last step. We will not be using this frequency map beyond this, so it is not necessary to mark its frequency 0, so we can skip this step. Then we will come to I. Okay, for all these the frequency will be 0 already, so they will not be added. Okay, so then I will be added, and we will be done with the whole result formation. Okay, you can say in a way. So this will be our result. Okay, so things will be more clear in the implementation part. So let's have a quick look at the implementation which is done in Java. Okay, and the C++ code will also be provided to you. So for those of you who prefer C++, can definitely check it out. So this is the implementation code. First of all, as we discussed, we will be needing a frequency map to store the frequency of characters in the first array. Okay, so here we are storing the frequency of characters in the first array. Then we will be traversing the second array, and we will be using a variable index, as we talked about, this variable, which will be used to point to the insertion index at which insertion is to be done in the first array. Okay, so in a way we have stored the contents of the first array, so we will not be needing any extra space, we will just be modifying the first array itself. Okay, so what we will be doing is we will be visiting the elements of the second array one by one, as we talked about in this manner. Okay, and while visiting the elements of the second array one by one, we will see what are their corresponding frequencies of those elements in the first array. Okay, so you can say first array frequencies, first array frequency. So what you will be doing is you will be adding the current number, frequency number of times to the first array. Okay, and then you will mark its frequency in the frequency map as 0. So this is this step, that we are visiting elements in the second array one by one using a, then we will be using a index variable to point to the index in the first array at which insertion is to be done, and then we are marking the used frequencies as 0. Okay, the numbers which have been used, their frequencies as 0. So then for the last step you will be checking are there any remaining characters left whose frequency are still not used. Okay, so this will be for the elements present in first array only. Okay, and they will be sorted, they will be present in the sorted order because of use of this tree map. Okay, have you been using hash map, it would not have been sorted in the ascending order for sure, that's why we are using tree map. Okay, so you can in your language of choice you can search a equivalent data structure, you can google it out or you can use ChatGPT for it. So then moving further, we will be just like the above step, finding what is the frequency, first array frequency, and then we will be adding this element that number of times to the first array, and then we will be returning the first array as our modified array, in which the sorting is done in relative order as per the order of occurrences of elements in the second array. Okay, and keeping remaining elements of the first array in ascending order. So this is the whole implementation, and let's have a quick discussion on the complexities also. So time complexity wise, you can see that uh, if let's say the size of the first array is given to be n, okay, and the size of second array will be definitely either be equal to n or less than n. Okay, since all the elements in the second array were present in the first array, so this loop will run order of n number of times. Okay, and not exactly order of n, order of n log n, you can say. Okay, because of use of this tree map. Okay, and this particular loop will be running for how many number of times. You might be thinking that it will be somewhere around maybe order of n square or something, or more than order of n, but it will be order of n only, since every element in the first array will be visited only once. Okay, that's why close to order of n, you can say. And the last uh, you know loop uh, will be running less than order of n maybe, or you can say order of n, a loose upper bound. Okay, so overall time complexity will be, order of n log n, because of use of sorting with the help of tree map. Okay, so this will be the time complexity order of n log n, where n is the size of the first array. Space complexity wise, let's say all the entries are occurring only once, then it will be order of n because of use of this tree map. Okay, so these will be the complexities, and this is the approach. I hope you are able to understand it. Still, if there are any queries left, or you have any other type of queries, so you may ask them in the comment section. I hope this solution walkthrough added some value to your journey of owning your DSA skills. I will see you in the next video. Till then, keep practicing and keep solving problems. Thank you for watching.